For centuries, we believed this was the only way.
Planets orbiting in the habitable zone, where liquid water could exist on the surface, kissed by a star.
But this is a lie. This is Europa, a moon of Jupiter.
Its surface is a frozen wasteland, colder than our deepest Antarctic night.
But the most exciting frontier in the search for life is not on the surface. It's beneath it. Because and beneath that shell lies the single most promising target in our solar system. An ocean that holds more water than all the oceans of Earth combined. This is episode 3. How do we know it's there? This isn't just a guess. In the 1990s, the Galileo spacecraft flew it.
What it found was astonishing. The moon had a disrupted magnetic signature, one that could only be explained. Then there's the surface itself. It's not a solid, ancient block. It's cracked, shattered, and twisted into chaos terrain. Regions where the icy crust has clearly broken apart, shifted, and refrozen, as if it were floating on something vast and liquid below.
But the true smoking gun wasn't found at Jupiter. It was found at Saturn.
This is Enceladus, one of Saturn's moons. In 2005, the Cassini spacecraft Cassini did something incredible. It flew right through them, and it tasted the ocean.
It found water vapor, salts, and, most importantly, complex organic molecules and tiny grains of silica sand.
That silica is the key. Those tiny sand particles can only form when hot, minerals.
This was definitive proof. Miles beneath the ice of Enceladus, there is a hot, rocky seafloor. There are hydrothermal vents.
So, how could life survive in this total darkness, miles beneath an icy shell?
On Earth, the sun is the base of the food chain. In a dark ocean, what would life eat? The answer was found on our own planet. In 1977, scientists exploring the deep ocean floor found this.
Entire ecosystems, divorced from the sun. The creatures here don't eat sunlight. They eat chemicals.
This is chemosynthesis. At the base of this food web are not plants, but bacteria and archaea.
They thrive on the cocktail of chemicals gushing from the vents. Methane, hydrogen sulfide. They take
But what provides the heat? What powers these vents? The answer is gravity. These moons are in a constant, brutal tug of war. The immense gravity of their parent planet.
This process is called tidal friction. It generates enormous heat, melting the ice to form an ocean, and keeping the rocky core geologically active. It creates volcanoes and hydrothermal vents on the seafloor.
This means these dark oceans have all 3 ingredients necessary for life as we know it.
So, what could be living there? This is no longer wild fantasy. This is plausible science.
The base of the food web would be the chemosynthetic bacteria, forming thick, slimy mats around the glowing, hot vents.
Europa Clipper's way.
measuring the ice, and even sampling the plumes that may be erupting from its surface.
For all of human history, we have looked up at the stars and asked, are we alone?
We've searched for life on distant, Earth-like planets. But the first, definitive discovery of
It may come from a cold, icy moon, right here in our own backyard.
Hiding a dark, warm ocean, teeming with an ecosystem we have, until now, only been able to imagine.